Hello everyone, welcome to Incredible Study. Today under chemical bonding topic, we are going to discuss covalent bond, which is our second bond type. So without getting delay, let's get started. As we have studied in the second lecture of this chemical bonding topic about electrovalent bond or ionic bond, and in case of ionic bond, loss and gain of the electron takes place for the formation of stable bond. The loss and the gain of the electrons cannot take place between the similar atoms or the atoms having similar or nearly equal electron negativity. So during this, the mutual sharing of electrons takes place for the formation of bond, and the bond formed so is called covalent bond. The atoms involved in the bond formation share equal number of electrons, and the shared electrons become a common property for both the atoms and constitute bond between them. And the shared pair of electrons which is responsible for the formation of bond is called bond pair electrons. And the number of electrons shared by an atom during the formation of covalent bond is called covalency of an atom. And this covalent bond is denoted by dash, which is solid dash. So here we are going to write about this. Here you can see this is covalent bond, and this is detail about covalent bond. The number of electrons shared by an atom during the formation of covalent bond is called covalency. So here number of electrons shared by an atom during the formation of covalent bond is called covalency. Or we can also say covalency, define covalency as this: the mutual sharing of valence electron to attain the stable electronic configuration is called covalency. And this covalency only exists between non-metal and non-metal or two electronegative elements. And here the bond is denoted by solid dash. For single pair sharing, single dash, and for double pair sharing, double dash, for triple pair sharing, triple dash. And here the bond which is formed due to the mutual sharing of electron or due to covalency, it's called covalent bond. Here we write definition. The bond. This is the definition of covalent bond. The bond formed by the mutual sharing of electron between electronegative elements or non-metals is called a covalent bond. And this bond is denoted by here solid dash. You can remember solid dash. Okay. And for single pair sharing, if the single pair electron is shared, then we denote it by single dash. And if double pair electron is shared, then we denote it by double dash. And if triple pair electron is shared, then we denote it by 3 dash. Here now we take example for covalency. We show covalency by taking example. So we take oxygen as example. Here we know the electronic configuration of oxygen, that is 1s2, 2s2, 2p4. Here this is 6 and this is 2. And now we see in O2 molecules, 2 oxygen atoms combined together, and its valence electron is 6. Here you can see this is 6. So 1, 2, 3, 4, 5, 6. We write it this side 6. And for another oxygen atom, 1, 2, 3, 4, 5, 6. And here this each oxygen atom requires 2 electrons in its valence shell to complete stable electronic configuration. So this atom share we can denote it by cross. And this oxygen atom share electron, and this shared electron become common property of this oxygen and this oxygen atom also. And here we can show bond like this, double bond, because 2 pairs of electrons are shared. 2 pairs of electrons, you can see 1, 2, 1 pair, and 1, 2, 2 pairs. So here 2 pairs of electrons are shared, so we denote it by double dash. And here remaining. So here now we define 2 terms here, bond pair and lone pair. So here the electrons that take part in the formation of bond is called bond pair. So you can see these atoms take part in the formation of bond. So these electrons are bond pair. These are bond pair. and these electrons haven't take part in chemical reaction, or that is bond formation. So these electrons are known as lone pair. So here we can define bond pair, that the number of electrons that take part in the bond formation is called bond pair, and the lone pair as the number of electrons that doesn't take part in the bond formation is called lone pair. And now we see some examples of covalent bond, and here we are going to take this example to show the formation of covalent bond in these compounds. So here first number, nitrogen, that is N2 molecule, and we know atomic number of nitrogen is 7 and electronic configuration is 1s2, 2s2, 2p3. This is electronic configuration of nitrogen atom, and this is the valence electron of nitrogen atom. Here we take two nitrogen atom. Here two nitrogen atoms are combined together. So here we take two nitrogen atoms, and here we write its valence electron. 1 2 3 4 5. 1 2 3 4 5 here, and here you can see each pair gets shared, each pair of the electron get shared, and altogether 3 pairs of electrons are shared between these nitrogen atoms. Therefore this results in the formation of triple covalent bond, and these are lone pairs. So here this is the formation of bond, that is covalent bond in nitrogen atoms. And we take second example here, oxygen, O2 molecule, and we know atomic number of oxygen is 8. So here electronic configuration 1s2, 2s2, 2p4. This is the valence electron. Valence electron of oxygen is 6. Here we take two oxygen atoms, because two oxygen atoms are combined together here, and here 1 2 3 4 5 6. This is the valence electron of this oxygen atom. 1 2 3 4 5 6. In the same way here two pairs of electrons are shared. Here two pairs of electrons are shared. So this leads to the formation of double covalent bond between these atoms. So here these all are lone pair electrons. These and these are all are lone pair electrons. And this is the formation of covalent bond in oxygen molecule. Now we take 3 number example, that is H2O, water. H2O. And here we know the oxygen has 6 valence electron. So 1 2 3 4 5 6, and hydrogen has only 1. So here you can see one pair of electrons get shared between one oxygen atom and one hydrogen atom. So here in this side also. So this leads to the formation of covalent bond in H2O molecule here, and this is not the actual structure of H2O. This is the actual structure of H2O. Later we will discuss this in another topic. And fourth number here, NH3. So here I am going to rub this, and here fourth number is NH3. Here one nitrogen atom and 3 hydrogen atoms. So we write 3 hydrogen atoms around this nitrogen atom, and we know nitrogen has 5 valence electrons. So 1 2 3 4 5, and hydrogen has only 1. So these electrons get shared between nitrogen and hydrogen, and here now we count the stability, that is valence electron of nitrogen atom, that is here 1 2 3 4 5 6 7 8. So octet state completed, and here this is the formation of bond between NH3. And now we see the formation of bond in here CH4, that is methane. And here 5 number CH4. Here carbon is central atom because carbon is only one. Here only one carbon atom is combined with 4 hydrogens. So here carbon get combined with 4 hydrogen. And we know atomic number of carbon is 6 and its electronic configuration 1s2, 2s2, 2p2 here. It means 4 valence electrons carbon has. So here 1, 2, 3, 4 and hydrogen has only 1. So one carbon requires 4 electrons to complete its octet state. So here it combines with 4 hydrogen in this way. So here only single covalent bond is formed in methane between hydrogen and carbon atoms. So this is the formation of covalent bond in methane. Now we take example, that is C2H2. This is our last example. Here 6 number C2H2. 2 carbon atoms are combined with 2 hydrogen atoms. So here we write carbon, carbon, hydrogen and hydrogen, as this combine with only 1 electron of carbon and this hydrogen combines with only 1 electron of this carbon. And now remaining 1, 2, 3. 1, 2, 3. Carbon has capacity to form triple covalent bond. So here you can see each pair get shared. Here 3 pairs are shared between these 2 carbon atoms. So this leads to the formation of bond. Here covalent bond. And one thing you remember, just start the formation of bond by this side. It means by lower side. So these are some examples or compounds that we have taken as the example to show the formation of covalent bond. And now we discuss our next topic, that is the types of covalent bond. Here covalent bond is categorized into 2 categories, on the basis of polarity and on the basis of overlapping of atomic orbitals. So here we first discuss on the basis of polarity. So here first on the basis of polarity. On the basis of polarity. So on the basis of polarity, covalent compound is categorized into 2 categories, that is non-polar covalent bond and polar covalent bond. Polar covalent bond. And here non-polar covalent bonds are the covalent bond that is formed between homoatoms. Here the bond formed between homoatoms. Here homoatoms means same atoms, same kind of atom. It means here oxygen between O2 molecule and 2 molecules, chlorine molecules, and so on, and here so on. So here we see in oxygen molecules, this is double bond. In N2 molecules, that is nitrogen, triple covalent bond, and chlorine atoms, that is single covalent bond. So these all bonds are non-polar covalent bond. These all bonds are non-polar covalent bond. And now polar covalent bond. So the covalent bond which is formed between heteroatoms. In this, the covalent bond formed between homoatoms, but just opposite of this, the covalent bond formed between heteroatoms. The covalent bond, and here heteroatoms means different kind of atom. Here heteroatoms means different kind of atoms. that is H2O, 2 atoms, hydrogen and oxygen atoms, HCl, hydrogen and chlorine atoms, CH4, etc. So these all are between heteroatoms, means different kind of atoms. So here we see bond formation in H2O, hydrogen, and here HCl, single covalent bond takes place, and here in methane CH4. These all bonds are polar covalent bonds, and these are the types of bonds on the basis of polarity. And now we discuss the types of covalent bond on the basis of overlapping of atomic orbital. And here now we discuss the types of covalent bond on the basis of overlapping of atomic orbital. On the basis of overlapping of atomic orbital, there are two types of covalent bond. First one is sigma covalent bond, and second one is pi covalent bond. It is also denoted as pi, and this is sigma. And before going to understand about sigma covalent bond and pi covalent bond, we have to be familiar with the shape of orbitals. That is, for s orbital we have spherical shape. S orbital are spherical in shape, and p orbitals are dumbbell shape. Similarly, d orbitals are double dumbbell shape. They are double dumbbell shape. In this way. And f orbital, the shape of f orbital is still unknown. We see in structure formation of sigma covalent bond and pi covalent bond. These types of covalent bond on the basis of overlapping of atomic orbital is very important for the examination point of view and for knowledge point of view. So here now we are going to discuss sigma covalent bond. Here sigma covalent bond. So here the bond which is formed, the bond covalent bond, here covalent bond formed. Here the covalent bond which is formed due to the head-on overlapping is called sigma covalent bond. Head-on overlapping means like this. It means these all surfaces. Head-on overlapping is two types of flat surfaces like this. Head-on overlapping. There are two types of overlapping. That is, first one is head-on overlapping and second one is lateral overlapping. Head-on overlapping means like this, and lateral overlapping means like this. So here the covalent bond formed due to the head-on overlapping is called sigma covalent bond, and they are a stronger bond. And here we take some example to show the formation of sigma covalent bond. Here we show formation of sigma covalent bond in H2 molecule, and we know for hydrogen atom electronic configuration is 1s1, and the shape of this s orbital is spherical, and we are going to show the formation of this H2 molecule. So H2 molecule, and here this is H plus H. One atom of this hydrogen and one atom of this hydrogen gets combined together, and this leads to the formation of sigma covalent bond. This is, and here one electron of this, here one electron of this atom and one electron of this atom get combined together, and this show the formation of sigma covalent bond. That is, this is, and this is the sigma covalent bond. Or we simply write sigma bond. And now we take another example to show this formation. We take our next example, HF, that is hydrogen fluoride. And for hydrogen we know 1s1, and for fluorine the electronic configuration of fluorine is 1s2, 2s2, 2p5 here, and its valence electron is 7. This is 7 plus 2, 9. This is the atomic number of fluorine. So here we see for this p orbital, here we write for p orbital 3 boxes. px, py and pz. So here 5 electrons, it means 1 2 3 4 5, one remaining, only one electron is required here in p orbital. So here H plus this, the shape for p orbital is this dumbbell shape, so we write here dumbbell shape, and here one electron of this hydrogen and one electron of this p, that is this fluorine. And now this leads to the formation of sigma covalent bond like this. This is the formation of sigma covalent bond, HF. That is, this is the formation of bond, and this bond is sigma bond. So here in this way we have understood about sigma covalent bond. Now we are going to understand about pi bond, pi covalent bond. Here now we discuss second type of bond, that is pi bond, on the basis of overlapping of atomic orbital. This is pi bond, and we can denote it by pi. So the covalent bond formed So here pi bond is the covalent bond which is formed due to the lateral overlapping. Lateral overlapping means these lateral faces are overlapped together. So these lateral faces are overlapped, so this is called lateral overlapping. And here this bond is formed by lateral overlapping of the atomic orbital, so this is called pi bond. And there is one condition for formation of pi bond. Pi bond only form after the formation of sigma bond. Suppose we consider here path A, B, C. Here is the condition A, B and C. If a person has to go to C from A, there is no any direct way to reach C. So the person has to go through this B. As similar way, if we have to form the bond, pi bond, then we have to pass through sigma bond. It means formation of sigma bond occurs first and then after pi bond. So pi bond only forms after the formation of sigma bond. So here we write condition for the formation of pi bond. So what is the condition? Pi bond only forms formation of sigma bond. So here now we take one example to understand the formation of pi bond. Here we take oxygen, O2, right? We know electronic configuration of oxygen, that is here 1s2, 2s2, 2p4. Atomic number 8. So here 1s2, 2s2, 2p4. Here in p orbital 2 electrons are lacking. It means it needs 2 more electrons to fulfill this p orbital. So here we write for p orbital there is 3 suborbitals, that is px, py and pz. So here 2, so we write here 2 2, right? So here now in this is the filling of electron 1 2 3 and 4. Here you can see these 2py and 2pz are empty. It means they need altogether 2 electrons. And now we are going to draw the structure. Here you can see the structure of p orbital, that is dumbbell shape, and here this is only one, but we need here y and z. So we have to form this like O2. Here O2 is going to be formed. Oxygen, 2 oxygen atoms are going to combine and pi bond exists between them. So here we draw pi bond for O2, right? So here 2 oxygen atoms, so here we have to draw 2. You can see here. here for one oxygen atom, and this is for second oxygen atom. This is 2py, and this is for 2pz. 2py and 2pz. Here you can see these two oxygen atoms get combined. This is also one oxygen atom, and this is another oxygen atom. So here one electron of this oxygen atom and one electron of this oxygen atom. So here, sorry, this is not 2pz, this is 2py and this is 2pz. This is 2pz. So here one electron here and another electron here. So here first these two electrons get combined. It means head-on overlapping takes place between them for the formation of sigma bond. These two electrons get overlapped by head-on overlapping and sigma bond is formed between them. So here this is addition, and now we show the formation of this bond here. Now here I am going to show the result over here, formation here. Just we rub here plus, and then after this orbital gets combined. It means overlapping takes place here, head-on overlapping takes place. So here directly we can write in this way, this is like this, and for this electron gets combined, and this is head-on overlapping. Alright, and here lateral overlapping takes place between this 2pz and this 2pz. So here we show lateral overlapping by denoting arrow over here. Alright, this is lateral overlapping. Here now we write bond for oxygen, that is O2. Oxygen, one bond, two bond. Here you can see one lateral overlapping means one pi bond is formed here and one sigma bond. So here one is sigma bond, another is pi bond. This is the formation of pi bond in O2, that is oxygen molecule, two atoms of oxygen. And now we show the formation of bond in nitrogen. And here now we take another example, that is nitrogen N2. And we know atomic number of nitrogen is 7 and electronic configuration is 1s2, 2s2, 2p3. Here there is only 3 electrons in p orbital. It means it requires 3 more electrons here in p orbital. So here we show p orbital as this. We see the electron filling of electron in p orbital. Here 2px, 2py and 2pz here. First electron this, second this, and third this one. This is the filling of electron. There is only 3 electrons, 1, 2 and 3. It means here it requires more 3 electrons to achieve octet state, right? So here now we show formation of this pi bond in N2 molecule. Here for this we have to write N and 1, 2, right? This is X2 and Z here. This is Z, right? Similarly, plus for another nitrogen, this is 1, 2, and here 3. Now you can see here this is 2px, 2py, 2pz. Now here similarly this is also 2px, this is 2py, this is 2pz. And similarly here 1, 2, 3 electrons is required. So here first 1 electron, in second here same thing, we write here 2py, second electron, and here third electron. Similarly in this first electron, but here consider this should be of opposite direction. Similarly here second electron, here third electron, and here now we show the formation of this pi bond in this N2 molecules. So here we just these two get overlapped, head-on overlapping takes place between these two, this and this, and similarly here between these 2py and 2py lateral overlapping takes place, and also between these 2pz and 2pz lateral overlapping takes place. So here we show lateral overlapping in this way. This is for 2py and this is for 2pz. This is the formation of pi bond in N2. So this becomes head-on overlapping, right? It means sigma covalent bond. So here 3 bonds are formed there. 1 bond, here this 2 bond, and here this 3 bond. 3 bonds are formed here. So here in between N2 we see 3 bond, formation of 3 bonds, and among them one is sigma bond. This is sigma bond, and here this is sigma bond, and here this is pi bond. Similarly this is also pi bond. So here we have finished our topic, that is pi bond. This is the formation of pi bond, and here we take one more example to understand more clearly, and this time we take another example, that is C2H2. C2H2. So here you are asked to show the pi bond and sigma bond. Here we just write this. C2 means 3 bond and H2 means single bond. This is Lewis structure, C2H2, and here among these 1 is sigma bond and 2 are pi bond, and similarly because there is only 1 bond, so this is sigma bond. You have to consider this is sigma bond, because here if there is only 1 bond, then think that that is sigma bond, no other than sigma bond. If there is 2 bonds, then in that 1 is sigma bond and another is pi bond. If there is 3 bonds, then 2 are pi bond and 1 is sigma bond. So here these are bonds present in C2H2. Here now we discuss very important question, that is why sigma bond is stronger than pi bond. Obviously sigma bond is stronger than pi bond. So here now we write answer and then we discuss it. Here you can see this is our question, sigma bond is stronger than pi bond. Why? As we know, in sigma bond head-on overlapping takes place and in pi bond lateral overlapping takes place. So the strength depends upon area of overlapping, and in sigma bond head-on overlapping takes place. So it occupies more area. Area is greater in head-on overlapping, but area in the lateral overlapping is smaller. You can see this is lateral overlapping, so area is comparatively smaller than this head-on overlapping. So here since this strength depend upon area of overlapping, sigma bond is stronger than pi bond because there is head-on overlapping, the area of overlapping is greater. Same thing here is written, as head-on overlapping takes place in sigma bond and lateral overlapping takes place in the pi bond. So the overlapping area of head-on overlapping is more than that of lateral overlapping, and strength depend upon area of overlapping. So sigma bond is stronger than pi bond. This is the answer of this question. Sigma bond is stronger than pi bond. Why? So here now we discuss properties of covalent bond or covalent compounds. So here first number, they are found in gases, liquids or solids. So these are the states in which they are found. They are oftenly found in gaseous state, liquid state or solid state. And here second number, they have low boiling and melting point. They have generally low boiling and melting points. Third number, covalent compounds are generally soluble in nonpolar solvents like benzene and carbon tetrachloride etc., but insoluble in water and other polar solvents. Here nonpolar solvent means pole is not generated, it means pole is not created. Here they are soluble in nonpolar solvents like benzene, carbon tetrachloride etc., but they are insoluble in nonpolar solvents like water. They are insoluble in polar solvents like water. Fourth number, since covalent compounds have no free ion to conduct electricity, so they are bad conductor of electricity. But in case of graphite, each carbon atom possesses one electron, that is one free electron, so they are good conductor of electricity. Same thing here, since covalent compounds have no free ion to conduct electricity, so they are bad conductors of electricity. But graphite have one free electron on each carbon atom, so it is a good conductor of electricity. Fifth number, reaction of covalent compounds are generally slow because they are molecular, and in this breaking of old bond takes place and formation of new bond takes place, so they are quite slower than these electrovalent compounds. The reaction of electrovalent compounds or ionic reaction simply we say. Sixth number, they are directional in nature. They are directional in nature, it means the bonds get formed in fixed direction. For example, if we take water here H2O, then we cannot write this like this here. Since these covalent bonds are directional in nature, we have to show this like this. This is actual structure of water. This is actual structure of H2O. This is wrong. If you write in exam, then you should write this one because that one is correct here, because it is the property of covalent bond. They are directional in nature. Here 7 number, covalent compounds can show isomerism. Here isomerism means to form isomers, to show isomers. Here isomers means they are the compounds having same chemical structure. It means same chemical formula but different physical structure. Here 8 number, they are neither hard nor brittle in nature. Covalent compounds are not generally hard and brittle in nature. They are soft in nature. So here these are the properties of covalent compounds that we have discussed here. So in this video we have understood detail about covalent bond, and next part we will be discussing about coordinate covalent bond. So stay tuned for next lecture.